Hello student, today we are going to see full projectile motion. The object is going to cover with the full projectile motion. It's going to start from one point end with another point. Okay, the object is going to cover with the full projectile. So the point today we are going to discuss is a trajectory equation, time of flight, maximum height and horizontal range. Okay, these are the concepts today we are going to discuss. Okay, so the object is thrown at the velocity of v0 at some angle. Okay, so velocity at x-axis and velocity at y-axis. First we should find velocity at x-axis and velocity at y-axis. So the object is thrown at diagonally this side with the velocity of v0 with the angle of theta. So I am taken this as a triangle. That means adjacent side of the triangle will be adjacent and opposite. Adjacent is equal to v0 cos theta because adjacent by hypotenuse is equal to cos theta and opposite by hypotenuse is equal to sin theta. That means we come to know x-axis, the velocity, initial velocity in x-axis v0 cos theta and initial velocity of y-axis v0 sin theta. So when the object is going up slowly, the final velocity is going to be final velocity in y-axis will be 0. Okay, the velocity of initial velocity is v0 sin theta, final velocity is 0 when it is going up. Okay, so we can take it's going opposite to the gravity g minus. Okay, when it's coming down, the initial velocity of y-axis we can take it 0, final velocity is going to hit something. Okay, it's going to have some velocity. Okay, now we got x and y plane. Okay, so explain the velocity is going to maintain as a constant. The horizontal velocity is v0 cos theta. Wherever you are taking the v0 cos theta is going to maintain as a constant. In case here you are taken, it's a v0 cos theta. In case here you are taken, it's going to be a v0 cos theta. And also gravity we are going to take it as a 0 because x-axis there is no gravity. Okay, when the object is going up because of the gravity, when object is thrown because of the gravity, finally the object when it is at top, it's going to become as the rest. Okay, when it is coming down, slowly the velocity is going to increase. Finally it's going to have with bigger velocity. Okay, so when throwing up, the gravity will be the negative. When it's coming down, the gravity will be the positive. Okay, so x-axis velocity will be v0 cos theta, which one is going to maintain as a constant. Okay, in x-axis gravity we can take it as a 0. It's the same thing y plane. Okay, so that means so y plane, this is a y, it's a going up and coming down is a y plane. Initial velocity of y-axis we consider it's a v0 sin theta and final velocity of y-axis we can take it as a 0. It's a point A to B. Okay, so initial velocity of this much, final velocity I am taken as this much. Okay, so as I said, we are going to discuss in this video. First is the trajectory equation. Okay, so we will see what is a trajectory equation is going to tell. Okay, so trajectory equation is going to represent as a it's a trajectory equation. So I am taken the x displacement as the x. X displacement I am taken as the x. Y displacement I am taken as the y. Okay, so displacement of x-axis, displacement of y-axis. Okay, so y-axis, the x-axis, the gravity will be 0. So s is equal to ut plus of at square. So as we know, acceleration due to gravity is 0. So this going to be 0 in x-axis. I am taking everything as a x-axis. Okay, x and y, only the time is going to be the equal. X time you can take it as a y time, y time you can take it as a x time. Okay, so displacement in x-axis I am taken as a x. Velocity of the x-axis is the constant, is the v0 cos theta and t. That means plus 0 because there is no gravity. I am taken as a 0. So t is equal to x by v0 cos theta. So I got t as this much. So explain time The same time you can take it as a y plane also. Okay, so s is equal to ut plus of at square. I am taken as a y plane. Okay, the plane of y. Okay, sorry, the plane of y, that is called vertically. The object is going up and finally it's became rest, then it's coming down. Okay, so displacement of y axis y, initial velocity of y axis is v naught sin theta, then minus the opposite gravity. When the object is going up, gravity is the negative, so t will be there, minus of gt square. So as we know, t is equal to x divided by v naught cos theta. Okay, so same thing I am going to take it here. See, I think no need diagram. If anything, if we want, I will draw again the diagram. Okay, so y is equal to v naught sin theta, t I know, x divided by v naught cos theta, minus g of g t square. So t square means t is x square by v naught square cos square theta. That means v naught get cancelled. Sin by cos we can take it as a tan. Y tan theta into x minus g x square divided by 2. It's 2 times of v naught square cos square theta. Okay, so trajectory equation, when we can use the trajectory equation? See, example, the object is thrown from one place to another place. In between some wall is there. Okay, so object has to jump from this wall. If in case they are given as the y-axis, the wall height is this much. Okay, so the object has to go hit with this much. Okay, they will ask what is the maximum angle they can throw from the ground to overcome this obstruction. Okay, so this kind of question you should use as the trajectory equation. Okay, now I am going with the time of flight. Okay, so time of flight, time taken, first I am going to take it time taken for off projectile motion, and then I am going to calculate full projectile motion. So object is started here and it's going to come and hit here. Okay, so the time is going to be here. I am taken A to B. So velocity of y-axis is v naught sin theta. The final velocity of y-axis is 0. Okay, the final velocity will be 0. Initial velocity of y-axis is v naught sin theta. Okay, so as we know, v is equal to u plus at. So v is, it's a 0. Final velocity is a 0. I am taken it's v as a 0. It's a y plane. I am taken as a y plane. V as a 0. U is a v naught sin theta, and a is a minus g. Acceleration will be the negative. It's opposite to the ground, and t is a question mark. Okay, so this I am bringing here. So gt is equal to v naught sin theta. So that means t is equal to v naught sin theta divided by g. Okay, it is only the object is moving from A to B. Okay, A to B is taken as a t time. That means B to C is also going to take as a t time. So t plus t, we can take it as a 2t. That means the total time is going to represent as a 2t. So total timing we can take it as a t is equal to t plus t, 2 times of t. T1, T2, otherwise 2 times. Okay, so both the time going up and coming down, the time will be the equal. So 2 times of t, the total time is equal to 2 times of t. So t I know is 2 times of v naught sin theta by g is equal to t. So I got what is the time of flight. So time taken from A to C, the distance of A to C, I got full length time, how much is going to take it. Okay, in case if you know angle and what velocity you throw, you can calculate what is the time of flight, what is the maximum time it's going to reach from one place to another place. Okay, now we are going to calculate maximum height and horizontal range. Okay, so first I will calculate, I am going to calculate with the maximum height. So maximum height, this is the H max. So H max I am going to calculate. So y plane we have taken initial velocity will be v naught, initial velocity of y axis v naught sin theta. Final velocity will be y axis will be 0. The gravity acceleration due to gravity will be minus g. Okay, as we know, s is equal to ut plus of at square. So I know s is a maximum height, h max. So I think this equation is not going to use. Okay, so it's a v square is equal to u square plus 2as, which one is easy to solve. Okay, no need to use this equation because some of the time so this equation also we can get the answer, but it's going to be little long step we will get. Okay, so my suggestion, you will use for maximum height, you will use for the formula of v square is equal to u square plus 2as. You can ask me one question, why that equation is not suitable. Some places only specified equation will give the shortest way of the equation. Okay, so it is a y plane. Okay, everything is a y plane. Okay, so final velocity will be 0. Initial velocity I am taken as a v naught square sin square theta minus 2g. Displacement will be the h max. So from minimum to maximum. Okay, so h max I am going to calculate. So 2 times of g h max is equal to v naught square sin square theta. That means h max is equal to v naught square sin square theta divided by 2g. So I got what is the maximum height object can be travel. Okay, now we are going to see what is the maximum range the object can move. Okay, so maximum range means we have to include with x-axis also. Okay, so I am taken horizontal velocity is equal to horizontal displacement by time period. So horizontal velocity means this side, which one is going to be the constant. So v naught cos theta, horizontal velocity, horizontal displacement, the range of the object is going to cover, that I am taken as a r. So time period t I am taken. Okay, t is equal, r is equal to v naught cos theta into t. Already I know time is 2t, 2 already we found time is 2 times of v naught sin theta by g. This already beginning of the equation time of flight we already calculated. Okay, so r is equal to v naught cos theta into 2 times of v naught sin theta divided by g. So 2 times of v naught sin theta. Yeah, see 2 times of v naught square sin theta cos theta divided by g. That means 2 times of sin theta cos theta is going to represent the range is equal to v naught square sin 2 theta divided by g. So when the sin theta 2 theta is going to be 1, that is the time the range is going to be the maximum. That means v naught square divided by g. So 2 theta when it is 90 degree, that time it's going to get us the value of 1. That means theta is going to be the 45 degree. Okay, when the object is thrown at 45 degree, the object is going to cover the maximum range. Okay, this is a full review concept. Full equation I am given for the projectile motion. We learned from this video its time of flight, horizontal range, and maximum horizontal range, height of the maximum height of the object. Okay, and trajectory equation. Thank you. Thank you.
Thank you.